Hello everybody, I'm Jordi Freixa, and here I want to show you a little tutorial on the RelapPy package, which is meant for post-processing of RelapPy 5 calculations. I created this package a few years ago, and for me it was very useful. I installed it locally in my computer, and last year I decided to make it available for everybody, so I hope this tutorial gets you started with it and that you can find it very useful. So here I prepared, you see I have a couple of folders here with two examples that I want to show. So the first example is just a very simple example. It's a refloat example. So basically what we are having here, we have an input and it will be used for showing you some functions, and this is the relap input. It's just a fuel assembly in a pipe, so pipe is number 001, and we have time dependent volume at the bottom and at the top to represent the refloat of the fuel assembly. Okay, the fuel assembly is an 8 by 8 fuel rods. Okay, first of all we need to install the package, right? So let me first open here the terminal. So in principle, I understand that everybody who is using this package is familiar with with Python packages, so they have already installed Python correctly. And so if so, then you can install any package on the fly from the terminal. You would do pip install, and in our case, at the package name, okay, you can grab that from the website, and here you would install it. So in my case it's already installed, so it doesn't do anything. Another thing I recommend you to do often is, because this package is quite alive, is moving, so sometimes you need to upgrade it to the latest version. So you do it by pip install -u and again the name of the package. Okay, in my case I have the latest version, so it doesn't show anything. The second thing you need to know to install the package is tell Python where you have your executable in your system, your relap 5 executable in your system, because the Python package sometimes needs to extract data, or even if you want to run cases from within Python, you can do it. So if you are using Linux, you would do it with export the new environmental variable. And in Windows, this is what I'm working on. You would just open the environmental variables, and here in environmental variables you would create a new variable. Okay, in my case I already have it, but it's basically, this is the name of the variable relap exepath, and basically what you are telling is what is the executable file, and this will be used by Python later. You can change this at any time, just accessing here and change executable if you want to try different executables, or you can also change it within Python. So once you have loaded the package, you can change the executable there is a function to change the executable. Okay, let's try some of the things here. So of course you can do this in Jupyter Notebooks, but I'm not very fan of Jupyter Notebooks. I prefer to write my code completely and then be able to re-execute everything. Maybe because I'm old, I prefer this approach. So let me create here. I have the two examples. In this case, in the refloat, we have only the input file, and we have this file that I will address later what it is. But for the moment, just let's say that we only have the input file. So I'm going to create here a file just to try Python. So I create a new file. It's a Python file, which at the moment is empty. So let's start writing things. So here I have some snippets to make my workflow better. So this is tutorial for you. And let's first import the package, as you would do with any package. Import relap py as RP, okay. And I will also import pandas because we also will need some pandas functions. The package works with pandas functions, the way it stores the data and so on. Okay, I didn't run the case, so for the moment I only have the refloat.i function, so I would start by using, here you see, now text editors nowadays are so good, it shows you already all the possible functions that we can use in relap.py. So I'm going to first use this one, run case, okay. And in run case, what we just need to do is tell the name of the case. This is a string, as it's shown here. And that's it. I think with that, I can just run it. Let me move into refloat folder, and I start Python here. IPython. I like it to work like that. And then just run the tutorial. And you see now it's running already the refloat case as we specified, so it will take a while. Now it already finished. Let's refresh here, and you can see that now we have the refloat.o, the restart file, the screen file that it ran up to 500 seconds, so you can see here, okay. And that's it. Okay, let's go back here. Now I have run the case, so maybe I want to do some stuff. Okay, let's start simple. I didn't do much with these inputs, so I just want to plot a variable. Okay, so let's just use the function plot, and what the function plot requires is whatever alphanumeric variable that we want to plot, like you would do in apt plot. So let's just start with temp.g. You have to know the minor edits of relap, of course, and then we go for pipe1 cell10 0 0, that is 4 zeros, like we would write in a strip file. Okay, and then we need to tell that what restart. Okay, it's going to be refloat. Okay, but since I'm in Python, I can do easier. I can make it easier. All right, let's do it like that. Okay, and now refloat will be my case. So here I plot from case. Okay. Okay, now if I do that, it will run the case again and then plot it. But I don't need to run the case, so let me comment that line. And I go here to the terminal. I run again the tutorial, and if you can see here, plot has been saved as, okay, let's see. Okay, I have few files here. You see I have a dummy strip that was created with the temp.g pipe1 cell10. That's great. I have some strip f dot. I think this is the output of the data I requested, and indeed I have this png picture that we can see. It's already the plot. It tells me time s in front of volume, vapor, temperature, tg. This is what the minor edit in relap calls this variable. We see perfectly. Okay, I could now very easily go back to my Python, where I have it here, and I could just say, okay, but I want also the fluid temperature. Okay, so I can re-execute that, and now if I refresh, now I have also the temp.g. Temp f, okay, and now volume, liquid temperature, temp f. Okay, so all of that is quite easy to do. It's simple if you just want to extract some data. Let's make one first change I want to do is make it's going to get messy with all the files here, all the figures, so we can in RP there is a set function that we can set the figures type or the figures location. Figure type for me is okay. I can stick with the PNG, but let's put the location with a new thing. It has to be string, so I will create a folder figures. Okay, and let me delete some files here. I delete the figures. Okay, let's see now when I re-execute that, run tutorial.py. Okay, and see now the figure has been saved mg in folder figures. Let me refresh here. Indeed, I have the figures folder here, and I have my figure as I expected. Great. So one more thing about this one. So because now I extracted the data, but is there the data in Python? I want to do things with the data. And the answer is not at the moment, no. But you see, we can use that with a different way. And the way I want to do it is to create some variables with the data in 10, for instance, temg10, it will be equal that. Okay. If I rerun this now, you can see that more or less I got the same. I got the figure in the folder, but the difference now is if I check the variables that I have, now I have this temp.g that you can see here. Okay, so if I check temp.g, I have the data, extracted data. I have here I have it here in the Python, so I could start doing things like very simple to find the maximum value in temp.g. It would tell me what is the maximum temperature that we obtain, and do other stuff that we can be doing in a program. Okay, Python is very powerful. You can do whatever you imagine here. One more thing is sometimes in apt plot you can zoom in, you can modify the figure, and sometimes this is nice, especially for instance in this case. So I can use another setting that I can change, and that would be this one. Show plot. Okay, and now I put true. So now when I'm running the tutorial, you see it become stopped, so it didn't create the plot yet. And when I check here, I have the plot from matplotlib. I can make this bigger. Okay, and I can use these typical tools to make a zoom here, and then I can obviously save the figure in this format. I can do other stuff, so I can check around what is the result. So that can be interesting in this. Now it has finished. In this case, it didn't save the figure because I want to see it like that. Okay. Let me change this option. Wait. Let me try this. And still, now if these things that might be confusing at the beginning, so I comment that line, but the setting is still present, so I should change it to false to make sure it is not. Okay, now it doesn't show me the plot anymore. Okay. Let's do something else now, some other functions that we can use. Let's see what we have here. These variables refloat txt. Let's see what it is. Let me show it here in big. So this kind of table is replacing what you would do in the strip. So it is a little bit easier to write than a strip file, and it has more capabilities. So you do the same alpha and numeric part of the variables, and then but here then you can insert the tag, what you want to call the columns, what you want to see in the figures as a a variable, the units of the variables. So in general, Relap has already the units, but if you are using control bars, then Relap doesn't know the units. So here you can add it. You can add, if you want, this is optional, the initial time and end time of your plots. And general, we will show you later. Okay, so let me just first eliminate these two columns to see what happens. Let me save. Okay, let's go back here. What we are going to do first is extract the data. And to extract the data, we need to tell what is the input variables file. This is a string, so I will put variables, refloat. Okay, and then the restart will be case, and that's it. Okay, but if we write it like that, we will only extract it. Okay, let's do it anyway. Okay, so data has been extracted. Now if I refresh, I have the refloat.dat. Let's see what this is. So this is like everything that I mentioned there. It is extracted with all the variables. Okay. But at the moment I don't have it here. I cannot use it in here. So we are going to do the same thing that we say extract all the data, and also I want to store the variables. That the variables will be this file, variables refloat. Okay, and now if I run it again, so it happened very similar thing, but now if I type here data, I have all the data. You notice the name of the columns are the names in variables and so on. Okay, one next thing I can do after I have extracted is plot everything. So I want to get all the plots, so I will use a function plot all, and what I need to do is tell first the variable, the data frame in the variable. So already have it, variables, the case is data, and that's it. I want to plot everything. Okay, it's creating a lot of plots. You can see plot has been saved as figures. Okay, let's see. And here I do have all the figures. Let's see it here, and you see it has already decided the minimum and maximum time. In this case, it's coming from something before 0 and then after 500. And okay, there are other plots that we can see. Here is the cladding temperature and so on. Okay, but maybe I want to have initial and ending time. So here, let me bring back these two columns, and I will re-execute everything. So create all the pictures, and now we can see that the figure has been set with axis 0 and 500, and we can also change the axis in the temperature side if we want, with additional columns. Okay, so this is quite powerful because with the file here I managed to create presentable plots that can be already brought to a report perfectly. So they are well scaled, well shown. But let me show you the final application of this variables file. Is with this general column. This general column is optional. So if you don't put it, everything will be understood as a no. But if you put it, then you can create a very nice figure. In this figure, we will see three layers with different plots, and here you decide what you want to show in each plot. So I want to show the mass flow in the mid left axis. In the mid right axis I will show the inlet temperature, this in the top left, and so on. Okay, So let's activate it. I will delete this one. Let me just comment it. Okay, this function will be a general figure, and again we need to tell which variables we are going to do, the data, and that's it. Let me run. Okay, annotation location, so info general figure. The general figure was created, and here it tells you annotation location coordinates are as following. Okay, this is for advanced users, but let's see this picture. Let me refresh here. Indeed, general figure has been saved here. Let's see how the picture looks like. And okay, this is what we've got here. I think it's quite a nice figure, and if you notice, the software has already tried to find the best location to put the name of the variable. So core level, it has automatically put it here for you, which is, I think, in this case, quite a good location already. Quench front is located here, and the other are located in these positions. Okay, so this picture is quite nice already, but okay, we could make it a little bit better if you want to present it in a conference or somewhere, and actually you could do it here with the information that you have here. Let me general. So you have more variables to put here. I made the most simple way to generate variables and data, but actually you can also put experimental data if you want, and you can select the location of the tags, so you can change it to the right position. You can change the labels, list of labels of each y-axis, so you can change what is each variable, and you can change the limits in the x-axis, and you can change the title of the case. Okay, and if you see the default, it says UPC. Probably you are not part of UPC, so you would like to change that. Whatever. Okay, I run the case. MO1 now is whatever here. Okay, and we could change where these tags are, and we can change these labels easily in the calling of the function. So you can generate pretty nice picture already. All right, what else we can do? This is a refloat experiment, so it would be very nice to plot some kind of temperature profiles. Okay, let's do that. Let's create what we call RP plot profile. Okay, and you see here we can select alpha variable. We can select the number of nodes, or nodes where I want to do the profile, and the time at which I want to decide the profile, the restart case, and also case folder if you want to compare different cases as well, you can do that. But for here we have only one case. So let's do the plot profile, and first what I want to plot, let's put mg that we were doing before, and here the nodes is a list of nodes. Let me create it outside, and then the time, just put it at 200 seconds, and finally this is our case folder. I don't do anything, but nodes, it already warns me that there is no such thing as nodes. Let's create the nodes. It's a list, and it's a list of in the pipe 1. 0 1 1 2 3 4 zeros. I'm doing it like that to make it easier for me. You will see now. And there are 19 or 20 nodes. Okay, and let me put this in order. Okay, that's great. And let me delete this. So now I have it. All the I miss here a comma everywhere, and this one doesn't need a comma, and that's it. Okay, let's see how it works. So now I'm going to plot a profile of the temperature, gas temperature in all the nodes of the pipe 1. And indeed, plot has been saved as temperature profile. Let's refresh here. I'm getting a lot of plots. Temperature G profile. Okay, nice. I got the profile in time G. And nice thing now I have these. I can do, and I like to store the data. So temp G profile equal, usually it works like this, and but I want also the fluid temperature profile. So, and not only at 200 seconds, but let's create a few times. 100 point, 200 point, 300 point, 400 point, and 500 point. Missing here a comma. Times. Okay, so now I will create two profiles of temp G, temp F at different times across the whole pipe. It created the profiles. It's interesting also to notice that it makes a warning because the exact time 100 seconds is not found, so it uses the closest time. Oh, here I have very detailed simulation, so but at some point it could be important to know to reflect that. So let's see the plots. Temp F profile. Here we can see the fluid profiles at different times, and here is the gas temperature profiles at different times. Okay, and the good thing now is also then I have temp G profiles variable. Sorry. Like that, and I have all the data of the profiles, the temperatures at each node for the different times, so I can also, play around with this data that I just extracted. Okay. Another thing, final thing to show you here is I'm going to use this interactive plot. The data, okay, I already extracted data. Is my data frame, name of the interactive plot. I don't need anything else, just like that. So I use this variables file to extract data. Now data is called data here. Let's see what this interactive plot is. Run tutorial. Pam pam pam. The interactive plot has been saved as interactiveplot.html. Okay, I have it here. Let's open it. Okay, what do we have here? We have our base case, we have the inlet mass flow, and here I have different variables. Okay, I can select different variables. I can make a zoom, interact with it. This is why it's called interactive plot, and so on. It's a pretty nice feature if you want to just check around all the data in an interactive way. Okay. Okay, that's quite nice. Let's say we want to compare different cases. Okay, I have this refloat, but I want to make different cases, refloat 1, refloat 2, and then I would make folders to do that. So at case 1 a folder, at case 2 folder. Okay, and I would move the refloat, so copy to case 1 and move that one to case 1 as well. Sorry, case 2. Okay, so I have now two cases with refloat, all with the same file. Okay, I have this file here, but let's change the case 2. Let me change, for instance, the let's find, this is the inlet temperature or the mass flow. I can do it slightly slower refloat. Okay, so in case 2 the refloat is slower. Okay, let's come here. Now I will change a bit. So my case still refloat. I will put everything in figures. Let me put figures comparison, and I don't need that, but I want to run the cases. I need to put like that, case 1 plus case, and we can do it with case 2. That's it. I don't want to plot that one, but I want to extract here for everything. So the restart is case, but now case folder, I'm going to use case 1, case 2. So I'm going to add all the cases. I want to do all the cases, and cases equal list of cases, case 1 and sorry, case 2. Okay, in principle this will extract both cases. Here I'm changing that by figure all cases. I think that's actually sufficient. Here I can do that, and here cases, I want to do it for all the cases, but maybe it will be very messy with all the time, so let's just put one time. Just put the 300 seconds. Okay, and the interactive plot, I will also want it. Now it will run the two cases. Hopefully I didn't do anything wrong. Okay, it's running case 1. It's running case 2. I didn't do all the plots. Let me also do that to plot all the variables. So what I did here, let me add it here also. So basically I want all the plots of variables and data. And data now, it's not as before. Data has all the cases. So data, if I check it, it has that the case 1 and case 2. So it has everything. So when I call to plot data, it will plot the comparison as well. So let me go into figures.com here. in the file explorer, and you see all these files have been created. We can see that we are comparing case 1, case 2, case 1, case 2, and so on for all the figures I requested. You can see that case 1 is a little bit faster in recovering the core level, and we have the plot for the case 1 and as well the plot for case 2, and you can see clearly the differences. Actually, case 2 did not reach the quenching time yet. You can see inlet mass flow, one is 0.2, 0.3 as we did, and quench from top, quench from bottom very clearly. The temperature profile, now we are comparing case 1 and case 2 of the liquid temperature and gas temperature are obviously quite different at this time step. And if I move to the interactive plot, we see the comparison between the two of them. You can also unselect one of them to see one of them only, and this is very interesting plot to see the quench front propagation, how it's faster in one case and than in the other. We can make a zoom and so on. Okay, so you can see that this has been created basically with these few lines, basically setting the figure place, what is the case, the cases. Obviously, if you are in Python, so you can do more. If you have like 20 cases here, you could do let me bring this here, and here only 2 cases. I can write 2 lines, but otherwise I could do a 4 C in cases, run plus C, and this will do the same. And if I had 20 cases, it will also run each of the cases. Then I extract the data, I plot the general figure, I make all the plots, I make 2 profile plots, and I keep going here, run, and it's running case 1. It's running case 2. And it's creating a lot of beautiful plots. So I decide, but let's make a new case. So I can add a folder here, case 3. Again, I copy this one to case 3. Case 3, I go to the input, control forward, let's see, I find the flow, 2.3, okay, this one, let's put it a little bit faster. That's it. Let's go into the tutorial. Okay, now I have 3 cases. Case 3, sorry. Okay, let's run it again, and now it's running case 1. Should run case 2. Case 3. And creating all the beautiful plots. Okay, let me go to the folder with the figures. Now we have the 3 cases compared. Let's see, core level, very clear, maximum clouding temperature. We have the general figure for 1, 2, and 3. And obviously we have the temperature profiles for the three cases, and we have the interactive plot where we can look around, and maybe I don't want to see case 2, so I can eliminate it. I can eliminate also case 1 or add it, make a zoom, work very interactively, very fast, nice, I think. So I hope I try to make this first part of the tutorial. In a second part, in a separate video, I will address the second case where I work with more advanced functions, and with the case which is a little bit more complicated because it's a simulation of an integral test facility with more variables. Okay, so I hope you enjoy this tutorial and it motivates you to use the package. Remember, if you find bugs in the package, please report them to me. Also, remember that the package is delivered and there will be updates in the package, so keep updating it. Also, remember, if something is not working for you, remember that in most text editors, usually depends on your text editor. Here in NeoVim, if you press capital K with the plugins I have, it will bring me to the function itself where it is coded. So for instance, if I want to see how extract data, what is doing, or I have something is not working, I would press capital K, and it brings me where this function is defined, so I can check what the function does, and I can find an error if there is an error, and so on. I can also find what it returns, result, variables, and there are some more indications here. I think it should be usage, so it shows you how to use it, how to write it, and so on. So you can always go into this direction and find bugs or problems, or modify it for yourself. So that's the thing. For instance, the default for the general figure, the default is UPC, but you could come here in your, after you have installed it, you change that here, and the default will be your institution. So that's quite easy to do. Okay, but just keep in mind that every time you upgrade the package, this will be come back to UPC. Okay, so that's all. I hope you enjoy it and that you use the package. Thank you very much.